A fundamental aspect of psychology is how we perceive the world. The eye is the first step in this process. Knowing its structure will help me understand how light is transformed into neurosignals, which are then interpreted by the brain to create our visual experience. This is crucial for how we interpret the world around us. The activity 2.3, eye structure, allowed me to really understand the most important anatomical structures of the eye and the rough order that light moves through it. This is a side cross-section visual model I drew based off the model used within the activity that will aid my description of the parts of the eye. First, light moves through the cornea, which is a clear protective layer continuous with the sclera. It's not only a barrier, but it plays a crucial role in focusing light. Next, a light passes through the aqueous humor, a clear fluid filling the space between the cornea, lens, and iris. This fluid nourishes the cornea, lens, and removes waste and further aids in light transmission and focus. The iris, responsible for our eye color, regulates the amount of light entering the eye through the pupil, the hole in its center. This muscular diaphragm expands and contracts the pupil, shrinking it in bright light and enlarging it in dim light. The pupil itself isn't a structure, but rather than an opening. Behind the lens, which, along with the cornea, aqueous humor, and vitreous humor, refracts light to focus images on the retina. The lens can change its shape, thickening for close objects and thinning for distant ones, a process called accommodation. The ciliary muscle controls the lens shape. When it contracts, the lens thickens for near vision, and when it relaxes, the lens thins for far vision. The eye's interior is filled with vitreous humor, a jelly-like substance maintaining the eye's shape and contributing to light refraction. While generally clear, it may contain small particles that appear as floaters. The retina, a thin layer at the back of the eye, is where the light is converted into neurosignals. Cones and rods. The photoreceptor cells detect light and initiate this conversation. The fovea, a central depression in the retina, is densely packed with cones, providing the sharpest color vision. Signals from the photoreceptors travel through the retinal ganglion cells and exit the eye via the optic nerve. The pigment epithelium, sandwiched between the retina and sclera, nourishes the photoreceptors, provides pigments necessary for light detection. The sclera, the tough white outer layer, provides structural support. It's continuous with the cornea and surrounds the optic nerve. Finally, the optic nerve, formed by bundled axons from ganglion cells, transmits visual information to the brain. The point where it exits the retina creates a blind spot due to the absence of photoreceptors, which the brain fills in. I included all my references in the video description.